Hello, everybody. This is Eyal. This is the AI for the Enterprise Virtual User Group. We are here in Florida. I'm in Florida. I think our speaker is also in Florida, but somewhere else, and everybody else can be just about anywhere on the globe. It is 1 p.m. here and possibly morning time or evening time for some of you. And I welcome you all, and I will hand it off to our presenter today. She is from Qubole. She'll tell us a little bit about Qubole probably. And her name is Zhang. And I will move to her.
Hello, everybody. Thank you for attending. I'm very happy to have this opportunity to discuss with you on today's topics, building scalable data pipelines for machine learning. Just a quick introduction about me. My name is Zhang.
Man, perhaps turn on your camera. I think I did not even show my face, my mistake, but you can maybe turn on your camera and they will see you, at least for the time being.
Is it good? Can you see me?
I don't see your face. Okay, then let's continue this way. I'm sorry.
So yeah, as I said, my name is Zhang, Solutions Architect Qubole. I have over 20 years experience in software system architecture integration development. And last 4+ more years, I've been acting as big data architect. That's my LinkedIn profile. I'd like to quickly go over today's presentation agenda. Let's spend some time to have an overview for the process and the engines used in data pipeline building process for machine learning. And we are going to do a deeper dive into one highlight engine today, Airflow. And I will perform a live demo. Hopefully, we have enough time for Q&A. Many of us have received a text message, probably like this one, that we received text message from our bank saying that
we still don't see your screen. We don't see your share screen.
Oh.
Okay, we see it now.
Okay. That the bank asked us to verify a transaction until the action is taken. It's likely our credit card will be frozen. In order for us to experience this, the data scientists from our bank have to first build data pipelines for machine learning. Then they build and train a model. What we see here, it is model in operation. The model itself also allowed us to provide, to be interactive. So once we provide our response, we'll receive a message, things will go back to normal again. So this process for building data pipelines for machine learning has been around for a while. It starts with data exploration, then build the pipelines. Once all the pipelines are built, the data engineers will orchestrate the pipeline, which means a scheduling automating process in the operation. Finally, the data pipeline delivers data sets that can be further consumed by analysis or machine learning. So many, machine learning, many companies have machine learning AI data initiatives, but fail to provide a data product or deliver data product to the end users because there were so many challenges in data pipeline building process. Here, I just list a few, the most common seen challenges: data availability, scalability, complexity. Again, one of the common, issue company face is also a resource. There is not enough isolation to separate out data engineering tasks from machine learning tasks. A lot of times, data scientists spend over 70% of their time just do data cleansing, transforming, acquiring data. Instead, developing, testing, validating the model. So, which as a result that the validation test model process is not going through fast enough iteration. Hence, they are not able to provide business insight from the model in a timely manner. Let's quickly have a look at the commonly used engines and framework in data pipeline building process. Hive, Spark, and Presto are among the most popular choices. I have listed Airflow here, which is not quite an engine for compute. However, it is vital in orchestrate the pipeline building process. We will have a detailed overview on it in the later session. Let's take a closer look of each engine. Apache Hive, many of us are very familiar with it. It's great for ETL process, data exploration, batch processing on large workloads. Very distributed, scalable, and flexible with a high fault tolerance. The other popular choice of engine, Apache Spark, is well known for its in-memory massive parallel processing. Again, it's used for batch processing ETL, streaming, and a very popular choice for machine learning. Basically provide good compute engine for notebooks. Again, it's distributed, scalable, and fast, and flexible with very high fault tolerance. The other open source engine, Presto, is known for its very quick response time and very suitable for interactive optional queries. It can federate queries. Basically, what that means is that it doesn't require all the data to be located in centralized location. It can query where data lives. It's great source, great engine for data exploration and data delivery process. So we have process and a lot of choice for engines. How do I put them all together? Here comes one the choice or answers. That's Apache Airflow. Airflow itself, it is really a tool that does scheduling and workflow management. It can author workflow, schedule workflows, and monitor workflows. Now we have talked about Hive, Spark, Presto, and Airflow. Let's take a look, put them together to see where and when they fit in the data pipeline building process. Here it is a summary that we just gone through. In data exploration phase, we can use Hive, Spark, and Presto. And in the building phase, commonly use Hive and Spark because they are high fault tolerance. And deliver Hive, Spark, and Presto are good choices based on the workload requirement. In the orchestration phase here, we highlight the engine Airflow. So many of us wanted to know, how do I choose these engines? So here is the summary to categorize each engine's characteristics based on your workload and based on each engine's characteristics, then you can choose, which engine is best fit in your pipeline building process. Many data-driven companies have adopted a data architecture like this one. The data comes from various data sources, and data is ingested, stored on kind of data lake, and data is being prepped, cleansed for machine learning model building process, and the model will be trained, eventually will be served. Downstream intelligence tool can interact with the model, and therefore business intelligence or business insight can be obtained from the data that the company will take action based on the insight obtained from this pipeline. Data pipelines remain rarely trivial. There are many dependencies and sub-workflows, and also business requirements built inside the workflow as well. And failures in tasks is very common. So we want to ask ourselves, is there any technology or tools can help us put together? Now come to today's highlight engine, Airflow. Airflow is one of the answer. Now, why Airflow? Let's have a quick overview. What is Airflow and why Airflow can be a good choice in data pipeline building process? Airflow was started by Airbnb, later on joined Apache Foundation projects. It is the first scheduler under open source that really addresses many issues we see in today's scheduling workflow management space. It has very strong adoption in the community. 30% of Qubole customers of today have adopted Airflow as a part of a pipeline building process. And it's really great a great tool to resolve really hard matrix problem. And in a way, it's really changed people's minds how to manage workflow into a more agile approach from traditional ETL workflow kind of concept. Again, as we said, Airflow is a scheduling and workflow management tool, and it's Python-based service. That's another reason why it's so popular. And it's using DAG as a concept, very scalable. What is great in the big data world is that it provides dozens big data, cloud operation, kind of related operators. As we already said, it is Python-based service, and it has very rich command line interface to allow you to manage the Airflow cluster, Airflow-related workload. It provides web application for monitoring history tracking. Again, it's very distributed. It can run tens of thousands DAGs simultaneously. Let's go through some key concepts about Airflow. We all are very familiar with concepts like variables, connections, pools, queues. I will just talk about a few things that's Airflow specific kind of concept. One's the hooks. Hooks is really a way allow Airflow DAGs to interface with external systems, databases, platforms. And operators, it is each operator is really describe a single task. It leverages hooks to generate a certain type of task that later on becomes nodes in the workflow. XComs is a way to allow tasks to exchange messages and to provide better controls and to share states. So basically, DAGs in Airflow is a way to describe how to run a workflow. And the operator itself really determines what actually get done. There are many common operators provided by Airflow. For instance, we see here Batch, Python, MySQL, and Qubole also has its own set of operators that integrate with Airflow. You can easily develop your own operators based on your needs. Theoretically, a workflow can look as simple like this one. You start off a task, you're branching out, then you run few tasks in parallel, then you finish. However, in reality, your workflow is likely looking like this one. So how does such complex workflow is being described in Airflow by DAGs? I just go through a simple example how a DAG could look like in Airflow. So here, for instance, T1 is a task. It uses a bash operator. And the command simply, it does just issue a data command. And T2, T3 is similar simple operator. How do we define the relationship between T1 and T2 and T1 and T3? It is defined by using upstream, downstream concept. On the right side corner, you can see here we say T2 use upstream T1 and T3 also use upstream T1. So in the end, this DAG will look graphically like this way. Print date, that's the first task T1. You can task ID there, set print and score date. Will be run first, then sleep and templated will run parallel after print date task is done. All right, so I have gone through some basic engines, process, and some concept with Airflow. Now I'm going to do a live demo. How we can utilize the engines we just reviewed and put together a workflow. In today's demo, I'm going to use Qubole's Airflow engine and Qubole's Hive and Qubole Spark. And we are going to use a data set that's acquired from the internet, it's public data set. So in this workflow, we use Hive to create a database and create a couple of tables to use, utilizing the public data sets we acquired. And we use Spark engine to execute in a notebook. Notebook itself utilize the data or the tables, we should say, that's being created in Hive. Since we're going to use Qubole's data platform, let me just provide a quick overview what a Qubole data platform is. So Qubole data platform, it is a self-service cloud-native data activation platform for analytics, machine learning, and AI. It provides a single interface for all data personas. Doesn't matter if a data admin or data engineers or data scientists, they all use the same interface. It is a single platform for all data users. And it provides multiple engines for compute, workflow management. Here you can see at least Spark, Presto, Airflow, Hadoop, and Hive. And again, you can run Qubole data platform on different cloud, from AWS all the way to Google Cloud Platform. Now let me do a demo. Okay. All right. So I'm going to use the UIC environment for Qubole data platform, ui.qubole.com. I'm signing in. So in the home page here, as you can see, we have a list of user interfaces for data personas to use. Let me see, go to my clusters listing page. So I have started 3 clusters for today's demo. One of them is Airflow, and the other one is Spark, and the other one is a Hadoop cluster. All right, let me go to the Airflow cluster. I drop down here. As you can see, it provides different resources that you can use. This is the web application I talk about for Airflow. So in here, you can see I have a list of decks, and some of them being scheduled. And on the right side here, there's tons of links for you to run the deck, look into it, inspect tasks, and look in the logs, and so on and so forth. The deck I'm going to use today is movie reading ingest deck. Let me turn this on. Before I start to run it, I want to have a quick review what this deck does. Let me put a graphic view. Okay, so this is a graphic presentation for this workflow. First step is create a database for movie lens. Then it downloads the public data sets from the internet. And then it go ahead to create 2 half tables, one called movies, one called readings. And finally, it's executing Spark notebook. All this is going to be orchestrated by Airflow. Let's take a look at the code, actually. You click on the code here. It's a Python-based code interface. As you can see, the code itself is pretty simple. This is just the utilities. What does a web import script means is using shell command and does getting data sets and put into a certain directory on S3, okay, certain buckets. Then create a database script, basically just job and create database. Create table, basically job if it exists, otherwise create all external half tables. And this is the definition for the deck. So who owns it? You can define dependency when you want to run it. You can define retry mechanism. And here comes to the individual tasks. I have a task ID here called create movie lens database, as we see in the graphic view. All it uses using Qubole operator. This is our Qubole self-implemented operator. And it's using a have command. The query itself using create movie lens database. That's the script we just see on the top. Right here, create movie lens database. And here it tells you this Qubole connection ID is a way to let this task know which Qubole environment this Hive job is going to be executed. And if we don't specify any cluster labels, that's going to use a default. The cluster label will be default. Again, this is a similar task, Hive command. I'm not going to go through the details on it, just create the tables. And this one, the last one, is executing Spark notebook. We're also using Qubole operator. And the command is Spark command. And it tells you which notebook ID this is to execute. And the notebook name is movie recommendation notebook. And it tells you which cluster this notebook should be run at. The cluster label is Spark and Score 24. And the very last step is defines the dependencies or the sequence, how each task should be run. So here we can see the executing Spark notebook, and we'll start to run after we finish making movie half table, making half tables for ratings. Then the tool have tables, we use upstream import data from the web. Now finally, the import data from web actually depends on the finished job creating a movie line database. So this is in line with the graphic view we're seeing here. So we start off the first task, and then we go to the next task. Then we parallel run to create have tables. So finally, we executing Spark notebook. So before I start to run each of the job, let me have a quick review for the Spark notebook to see what it does. Now I come to Qubole's notebook interface. So this is a notebook we're going to run, recommendation for movie lens. Basically, it is a simple example of a recommendation system using the public movie data sets for movie lens. And the flow is such that data is going to be acquired and extracted by using public data sets and using Hive and Airflow. Then we do model building, scoring using Spark, of course, initiated by Airflow. Then finally, the model itself is going to be saved and recommended. The models, the movie itself, these models, in this example, only saved to have database. Of course, in many other ways, you can save it into object store like S3. Then you can go from there. You also can integrate with SageMaker, any other kind of tools to deploy and service from there. But for this demo purpose, we just saved into have database to illustrate the data building pipeline process. So the algorithm we're using here, it is called collaborative filtering algorithm, basically based on the common interest and features, we make recommendation. So here is example. It says that we have two persons. Both of them are outdoorsy, and they love to eat pizza and salad. One of them also drinks soda. So in the end, soda will be recommended to the other, which didn't have any preference being provided. Let's me quickly going through the notebook itself, what it does. Here, I will use really Spark ML library, and we read the data from the ratings, and we extract data. We group the data with our interest, and we then read the movie data. Same thing. We might group the data with what we need to do. Then we split data sets 80%, 20% for training and testing purpose. Then we run the model and do prediction. Eventually, we evaluate the model by using RMSE. And finally, we save the model into Hive database table called recommendations. And we just sampling. All right, now let me to run the deck. So I go back to the decks. And click and run. So you will see the deck will be running momentarily. Say here is already set as running. Let me just click on it. Go back to graphic view. Here is highlighted in green here means this is running. If you look at the state is running, let me click on this one. It's pop us certain things I can look into for the particular task run. One of them, I want to go to Qubole Data Platform, QDS. Here you can see actually this command being executed in the create movie line database. And on the Hive is a Hive query. In the query pane here, you can see exactly what the statement is. And when said here successful, if you are interested in what's being done, you can click on the logs. Basically, it tells you the detailed execution about this command. Now let's go. Now here you also can click on the logs. We provide you the detailed logs in case you need troubleshoot what it does in the back end, what the command ID was, so on and so forth. Now it's working on the task import web data. Same thing. If you click on it, you can go to Qubole Data Platform and visualize these commands being executed. And here it tells you exactly what step is this. Is a batch command. First, clean up the data and download data, and in the end, put the data into S3 certain buckets. While that's running, let's go to here again. So not only it provides you a lot of details on how your DAX is being executed. You can go to each task to see how long it took, so on and so forth. It also provides you a way to test and running the tasks. You can click on the details and some other widgets, to really manage this. All right, let's see where we are right now. So now it's executing parallel, creating the movie table and rating table. If I can go back to Qubole Analyze here, I can clear the search, go into the history. You can see these two tables are being created already, each one said successful. This is exactly the syntax, the statement is executed. Now it's running the notebook. We can go to Qubole's notebook interface. So we can see which steps is it's just running the import right now. While it's running, let's take a look. The Explorer here is allow you to explore the Hive metadata. Also, you can explore your object in object store. Here, let's say Amazon S3, and allow you to integrate with the external data source. See, I have Redshift and Snowflake being integrated as my data source. So for the database we're using here, called Movie Lens, you see already being created and the two tables being created. If you click on one of those, it gave me a brief view of table properties, and then you click on the rows, will allow you to preview a subset of data. So once the notebook is finished, we should see another table being created here in the Movie Lens called recommendations based on the code we just reviewed. Okay, here it tells you, give you a preview how the data looks like. Let me go to the notebook again to see where it is. Okay, so right now it's running the fate. It's a Spark job here. You can look into details. What it does, if you click on this one, will pop up Spark job UI. And then you can look into each stage, also look into executors and statements about this job execution.
Let me just interject for a moment because I missed the timing of this question. There was a question that said, is it like Amazon X-rays? I'm not sure at what point in the conversation it came up, but is any of the things, I guess, that you showed today equivalent to X-rays?
Yes, we use S3 as our object store here, data lake. So we read and save data into S3, the bucket. Is this the question?
I would wait for feedback from the same person who asked the question, and I'll be more alert this time. But let's continue, and
Okay.
they can tell us if we answer the question.
Yeah. Okay. So as you can see, this job is also finished. This paragraph is also finished, and now it's really running, saving the data into a Hive table here. See here, we can say here, we write the recommendation data into a table, and using Hive Lens database, and table name will be recommendations. It's doing this Spark job right now. Yeah, this job itself has a lot of stages. You certainly can always go in and to see more details, same as any other Spark job UI. By the way, the version I'm demonstrating here, the notebook, is Zeppelin-based. In next release of Qubole, we also fully support Jupyter Notebook as well. So you can run notebook in two of your choices. Yeah, then you can look into each of these outputs or tune your job based on the UI here provided. All right, while the job is run, there's any questions in the meantime I can answer?
Please use the chat box in the underneath the screen of the YouTube presentation, either underneath or on the right side of your video. Meanwhile, I can ask you a question, perhaps.
Okay.
More from the point of view of software development, this is a machine learning, but there are a lot of pieces of software, the scripts, the notebooks, and even configuration. All these can be looked at as pieces of code that you normally will save in, you will put under source control. Is there a way or standard way or best practice to use some kind of DevOps? So when somebody updates a piece of code, it gets deployed automatically or goes through some process of a review, going up the chain, etc. Or is it at this point still done more manually?
Right now, for notebook itself, we provide an interface integrated with GitHub. So you can always use Git as a version control. In the future release, we're also going to version the notebook. You can see 1 watt being changed. Currently in our backend database, we track on the each paragraph modification history, so that you know 1 and the watt being changed. So that's a modification synced from UI to the database in every 3 or 5 minutes kind of fashion. To answer your question, for CI/CD, what we recommend to our customer is you can put your source code. For instance, if you look at the Airflow DAG, it's nothing but a Python script. You can put it into your version control system. You can retrieve from there. Or a lot of our customers put on different, they put different, what should I say, they create different buckets for different purpose. Let's say your dev, QA, and production probably have different S3 buckets location. You can set a different access control based on how your environment is being set up for. Then you can create a different Qubole account, one for production, one for dev. Then your account using that S3 bucket location as default. There's many different ways the customer are using the system for CI/CD. Does that answer your question, Al?
Yes, very good answer. Meanwhile, I have a couple of comments from the audience. A very nice presentation. And is the presentation available for download? So let me just say the obvious. The YouTube video that you're watching now is going to remain on this channel, and you can watch it basically for as long as YouTube is around. But perhaps they meant slides or any other materials. So if that's a question to you, are you able to provide those materials, and how if you can, then how are they going to be available? You can maybe put a link. We can publish a link. If you have a link, I can put it in the YouTube itself. I can put it in the meeting comments. I can send an email to the members of the group, etc. But tell me what is your preferred method of sharing?
Yeah, I guess we certainly can share the deck. It's going to be difficult to share the demo contents, but let me show you. Okay, before I go to there, I just want to show you that the jobs, the notebook execution tool complete. So you see recommendation tables being created based on the machine learning model results. And here it said user ID, movie ID, title, and ratings. You can pre-sample all the data. Anyway, so let me go back to things I had to every time I need to share different things, right? I share this. Go back to my deck again. As I said, we should be able to share the deck I presented, but in order to, I don't think a way I can share the demo, but
can people get a free account for a while and then run demos themselves, or is there any arrangement that's similar to that?
We do have a Qubole training, like a labs, and also there is a test drive. You can sign up test drive, and in test drive you have all the functionalities you can use. The only thing is you cannot create a user, do some key administrative stuff, but you can create a notebook, you can use Airflow, you can run commands. Here, I'm going to this read deck as well, how to sign up in Qubole test drive. You can try it out and run there yourself, and feel free to reach out with your questions. I certainly can provide my sample code for the demo I use to the user who are interested to run it themselves. That's no problem. So any other questions?
I don't see any more questions. This is your opportunity, guys, to ask more questions live. After that, you will have to find your answers by, I guess, by reaching out to Man or looking in the resources. So let's give it another minute. But, oh, here is another question. We have Remy asking if is it a personal preference for language used like Scala versus Python?
Both in the notebook, both are supported, also support R as well. Let me quickly show you the capability what can support. Let me go back to my screen again. And also we support Presto notebook as well, which start to be pretty common for its interactive feature, nature of Presto. Let me go back to here. So let's say if you go to notebook here, right? I want to create a new notebook. There's many ways you can create a new notebook. You can of course create a new. You can upload from a JSON file or some other notebook you download. You also can import from certain URL. So let's say I just do a quick one. So just test. Here, locations type. Here you can choose Hive. Actually, we have not done too much more development for Hive. Presto is officially support now. But let's say we choose Spark. It's a very popular choice for notebook. And here you can see language itself is Scala, PySpark, SQL, Spark R. These are all supported.
Okay, that might have been more of a personal question, but do you have a personal preference?
In the data science world, right, PySpark is very popular, probably has a lot more libraries as well out there. So I've seen very common people are running PySpark notebook versus Scala. If a user, like to use a different interface, let's say analyze, this is where you can try out different commands here. And in here, for instance, let's try to let's say I want to use Spark, right? If here choose Spark, a lot of times people running a Spark command here using Scala. So you can specify your libraries, arguments, so on and so forth, just like you run the regular Spark program. You see here that you can choose whatever the clusters is suitable for. Some of them you might be integrated with different libraries. Like, for me, I have Sparkling Water, SageMaker, all integrated with certain cluster, run, geared for a certain workload. And here you choose Spark, you have Scala here, same thing. You can run SQL, R, and Python. But in this interface, Scala is mostly common see from our Qubole community. Does that answer your question? And by the way, all these jobs from notebook to analyze, you can schedule it by using scheduler for a synchronized execution. Airflow, as I presented, is more for complex, a lot of dependency kind of workflow. But if you just run a simple one, for instance, you want to executing one Spark command, and then you read the output from another Spark program, you can easily just using scheduler.
Yeah, I think you definitely answered the question.
Cool.
Any other questions? I'm looking to see if anybody else is typing anything in, but I don't. Oh, there is another question. Would you recommend using the R language for a specific type of work that you're doing?
R language, our language, mostly what we're seeing is associated with machine learning activity. So integrated with RStudio or mostly commonly used in the notebook, what we've seen. We are going to have even closer, tighter integration with RStudio. That's effort is underway to make the integration easier to use Qubole notebook. Or using R and executing the workload in Qubole Spark, let's put it this way.
Okay, last chance for questions. I guess that's it. If anybody wants to, okay, one more. Does the free developer trial can be used, that we can use, allow us to work with machine learning and pipeline?
Yes, I think so. Michelle, you can elaborate. I believe it has full functionality. Only thing, as I said, a couple limitation. You cannot create users. You may not be able to increase your account limits for resource. Anything else is a fully functional data platform.
So when you provide some links, that will be part of the links, right? To go and find out more.
Right. Yeah. Sign up test drive and take spin. Reach out to me or Michelle for assistance or questions. We certainly can help you to get that going.
Okay, great. That was very thorough, very enriching, very informative. So I'm going to show myself again for a second.
Hey, thank you so much for attending. Thank you.
Thank you very much. Thank you everybody for attending. Thank you, Man, for the great presentation. And we will have those links available, and we'll publish them in the YouTube. We can publish them also in the Enterprise AI Group meetup site. Thank you very much, Man. You can maybe stay with me a little longer, but I'm going to turn off the presentation, the online presentation. See you everybody next time.
Thank you again.
Okay, I'm afraid I cut you off in the middle. I should be a little bit more. I'm not sure if we lost Michelle or we just could not hear her at some point. But
I cannot hear her at all. I think she's on mute for some reason.
Can you hear me? Can you hear me now?
I can hear you.
Mon, can you hear me?
You can hear me, right?
I can.
But I cannot hear Michelle at all.
Yeah, I'm the only one who hear you. I mean, I can talk to both of you. It looks
sure.
She said she can hear me, but I cannot hear her. But that's okay.
Okay, these are the wonders of Hangouts, I guess. But I haven't seen this happen before, but it's not like
yeah, I mean, it's a little technical difficulties, but I assume everybody was able to view the contents okay, right?
Yes. They didn't get to see you actually, but they saw your presentation. So
no, that's okay. I think my presentation is more attractive than me, so that's okay.
Well, we did have people in the past that presented and they just didn't want to show themselves at all. They just put it on. But I prefer that the audience can see the speaker for a minute or two, but it didn't. So
especially, I mean, putting my shirt on rather than my pajamas. So, but I think it went okay overall. Hopefully, I made the message clear. What kind of tools they can use.
Yeah, I think you did a great job. Thank you again. If you have anything that you would like to present in the future, let me know.
Yeah, so I will send the deck to Michelle in PDF, so you can distribute it to, post it somewhere. That will provide maybe a little more information if people want to do the test drive. There's a instruction how to do it. As I said, it's a fully functional data platform. They pretty much can do almost everything on it.
Good. Yeah, I think that will be a good way for people to get started.
She said she'll create a Google Drive link. So, okay.
Okay, good.
Cool. All right. Thank you so much for having us. It's a pleasure to talk to you again.
Thanks, Al. Appreciate it.
Keep in touch.
Yep. Have a great weekend.
And have a great long weekend. Hopefully you're not working.
Yeah, I hopefully today it will be done. But yesterday and today was really, really busy. We were trying to just deploy something in a user acceptance testing, and we had a lot of difficulties.
I see. Because when you said you're still working, and it's almost 10 o'clock, I said, oh, okay.
Yeah, it's actually, I've been working there for maybe 8 months so far. Not very long, but that was the first time I had to stay beyond like.
Oh, that's not too bad.
Yeah.
Yeah, we all have our moments. Yeah.
Yeah.
Cool. Okay. All right. Again, thanks again, and keep in touch.
Thank you. I will. Bye-bye.
Bye.